Alright, let's look at the Laplace transforms of derivatives. Alright, so this is basically the essential property of Laplace transform. We can turn derivative into multiplication by s in a way. Alright, so it says this. If you take the Laplace transform of f prime of t, then this is equal to s times Laplace transform of the original function f of t minus f of 0. Right, so let's prove that first. Right, so we can say here Laplace transform of f prime of t. Right, so this is going to be equal to, so by definition, integral from 0 to infinity e to the negative st f prime of t dt. Alright, then we're going to use the integration by parts. So we're going to let u be e to the negative st and dv to be f prime of t dt. Alright, then by taking a derivative, so we know that the du is going to be negative s e to the negative st dt, and from there v is going to be f of t. Alright, so by using the integration by parts, so is uv is going to be, we have f of t times, actually, maybe I should write it in the same order, e to the negative st, then f of t. Alright, then you are going from 0 to infinity, so I'm going to do a b here, and here's a limit as b approaches infinity. Alright, minus. Right, so since there's a negative sign here, I'm going to turn it into positive, and the integral from 0 to infinity. Right, and s is just a constant, so I'm going to put s out here, and then you have e to the negative st, and the v is f of t, and the dt. Right. So you notice that we already see here this integral here is the definition of Laplace transform of f of t. Right, so we just have to evaluate that limit there. Right, so here we have a limit as b approaches infinity. Right, plug in b here, so you have e to the negative sb f of b, right, and minus, plug in 0, e to the 0 is 1, so you have f of 0, right. Then the second term is simply s times Laplace transform of f of t. Right? So as b approaches infinity, you can see that you have a e to the negative infinity, so this is going to approach 0. So this whole thing, first term, is going to approach 0, so it goes away. So what's left is here. I'm going to write this guy first. S times Laplace transform of f of t. Then you have a minus f of 0. Right? So that verifies this formula here. Alright, and once you have the first derivative, we can easily find the Laplace transform of the second derivative. Alright, so let's do that. So if you look at the Laplace transform of the second derivative, so f double prime of t, right? Because what we can do is we can use the first derivative formula. It's going to be s, then you have a Laplace transform of f prime of t minus f prime of 0. All right? But we know that the Laplace transform of f prime of t from the previous formula, so you have s times, then we can plug in s times Laplace transform of f of t minus f of 0, right? Then we still have minus f prime of 0, right? So if you distribute this s to the first term and the second term, we end up getting this. It's going to be s squared Laplace transform of f of t minus s times f of 0 minus f prime of 0. All right? So let's look at the third derivative. So we have Laplace transform of the third derivative, so triple prime of f of t, right? But we can just keep on doing the same thing. So this is going to be s times Laplace transform of one less derivative, so it's going to be f double prime of t. Then you just have to subtract the f double prime of 0, all right? Then what we can do is we can just plug in the previous result in here. So what you get is going to be s times, right? So previous result is s squared Laplace transform of f of t minus s times f of 0 minus f prime of 0. Then you're going to subtract f double prime of 0. All right? So this is going to simplify to s cubed Laplace transform of f of t minus s squared f of 0 minus s times f prime of 0 minus f double prime of 0. All right? So we're beginning to see the pattern. So if you have a third derivative, so start from 3, then s squared, and s to the first, and the 1. Then you have a Laplace transform of f of t. Then you have a f0, f prime of 0, f double prime of 0. All right? So following the pattern, we know that Laplace transform of, say, nth derivative of t, right? This would be, right? So the power is going to be n. So s to the n times Laplace transform of f of t, right, minus s to the negative 1, s to the n minus 1 times f of 0 minus s to the n minus 2 times f prime of 0 minus s to the n minus 3 times f double prime of 0. And then you just keep on doing that up until n minus first derivative of 0. All right? So that's the Laplace transform of the nth derivative of f of t. All right. So if you want, you can use a capital F. Another way to write that would be, this is going to be s times, and the Laplace transform we tend to use capital F of s minus f of 0. And we can do the same thing with this guy. So s to the n, capital S, f of s minus s to the n minus 1, f of 0 minus s to the n minus 2, f prime of 0, and so on. And you have n minus first derivative of f, evaluate at the 0. All right, so this is the Laplace transform of derivatives. All right, that's it. I hope that this was clear.